Imagine you're sitting at a drum set.
Go ahead.
It's a standard kit. And I tell you to play a really simple beat, but instead of just telling you to play it slower or faster, I tell you to play it mathematically backward and upside down.
Which just sounds like a riddle, right?
Right. I mean, what does that actually look like for your physical body? Like, how do your muscles even process a backward beat?
It's a crazy concept.
Right?
But it really forces us to confront how completely limited our standard view of rhythm actually is. I mean, we are so conditioned to view time as just this flat, forward-moving metronome.
Yeah, just tick-tock, tick-tock. 1, 2, 3, 4. It just marches endlessly on this perfectly straight line. But today's deep dive is going to completely shatter that flat track.
Definitely.
We have this fascinating stack of notes that reimagines musical time signatures, not as a straight timeline ticking forward, but as a literal, physical, three-dimensional space of energy. Before you panic, if you're listening to this, we are going to keep the math strictly in layman's terms, I promise.
Yes, we are not getting into the weeds of the equations here.
Exactly. The mission today is really to upend how you think about a simple beat. If you're listening right now, you probably know how to tap your foot or, tap your steering wheel to a song on the radio.
Oh, for sure. Everyone does that.
Right. But by the time we are done today, we're going to show you how that simple foot tap is actually this physical journey.
But to even begin building a three-dimensional model of time, we kind of first have to take our normal flat model of rhythm and just push it until it literally breaks.
We have to find the edges, yeah?
Right. We need to find the edges of human capability.
So let's start with the most relatable example from the drummer's notes, just to get our baseline. Think about good old 4/4 time.
The standard pop song beat.
Exactly. Imagine you have a drumstick in your hand and a flat table right in front of you. 4/4 time basically just means hitting the table 4 times. The table is neatly divided into 4 equal slots in your mind.
And you just strike downward.
Right. Tap, 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 tap.
But notice what is happening physically when you do that. Gravity is actually doing half the work for you.
Oh, that's true.
Right. The stick falls, the table receives the impact, and the sound travels up to your ear. The source actually calls this the standard positive direction of time.
It's incredibly clean. Everything exists on this neat little line. The stick moves down, which is the actual event, the beat itself. And then you lift your arm back up just to prepare for the next hit.
Right. The upward motion isn't part of the music.
Exactly. It's just the commute. It's a perfectly divided, super rational grid that our bodies just instinctively understand without even trying.
But the author of these drummer's notes introduces a twist that starts to break that physical comfort.
Oh, here we go.
Yeah. What happens if you change the denominator of that time signature? So instead of 4/4, let's say we move to 4/7 time.
Okay, so you are still hitting the table 4 times in a measure, but the table itself is basically divided into 7 invisible slices.
Yes. And the source describes this physical sensation so beautifully. When a drummer actually tries to lock into 4/7 time, the groove feels tilted.
Tilted. Wow.
You are technically playing on a rational grid. I mean, 7 is a real number, but your body cannot center itself. Gravity's still pulling your stick down, but the floor beneath you has this really strange alien symmetry to it.
It's like walking down a staircase in the dark, right? And all the steps are just a millimeter taller than your brain expects.
It's a great way to put it.
You don't necessarily fall down, but you stumble constantly. You just feel off balance. But as weird as 4/7 is, it's still just whole numbers. The text pushes this so much further by introducing an irrational time signature.
Oh yeah, pi over E.
Yeah, pi over E.
The breathing bar. This is where we leave standard musical notation completely behind.
We really do. Let's break this down, because when you first read it, it just sounds completely absurd. So instead of normal integers, you ask the drummer to hit the stick pi times per measure.
Right.
So roughly 3.14159 infinite hits. And you measure each hit as an eth of the bar, E being Euler's number, which is roughly 2.718.
And because pi divided by E never resolves into a clean fraction, I think it's roughly 1.1557, just stretching out to infinity, those two numbers will literally never, ever perfectly align.
Right. And the imagery used in the text here is a pendulum swinging. Imagine the actual physical swing of a metal pendulum represents pi, but the clock ticking in the background, which is measuring the time, is based on E.
So because they never align, The musical bar doesn't end on a neat boundary.
Exactly. It has a tail. It's like this tiny fractional breath at the very end of every measure.
Which means after one bar, your downbeat is actually slightly ahead of where you started.
Yeah.
And then after 2 bars, you're even more ahead. The grid is actually drifting.
You're drifting.
Yeah, you are no longer landing on a repeating digital lattice. You are physically playing a spiral.
Okay, I have to stop and push back on this exact point for a second.
Right.
Because pi and D, come on, no human drummer on Earth can actually sit at a drum kit and play an infinite decimal rhythm perfectly.
Yeah.
It is physically, literally impossible. So why are we even talking about it? Are we just doing, like, theoretical math puzzles for the fun of it?
Well, it is entirely impossible to play perfectly. You're right. But the point of the pi over E thought experiment isn't to write a pop song that someone can play.
Okay.
It's to completely break the concept of time as this rigid, repeating lattice.
Right, to prove that rhythm doesn't just have to be a grid of boxes we check off.
Exactly. Think about what it proves mathematically. By showing a rhythm that never perfectly synchronizes with itself, the source demonstrates that rhythm can be a continuous physical flow.
A flow, yeah.
It totally shifts our perspective from rhythm as a digital quantized timeline to rhythm as an analog physical reality that can drift infinitely.
Yeah.
It just frees us from the timeline.
So we basically had to break the flat grid to see what was actually underneath it.
Pretty much.
And once we accept that rhythm can drift off that neat 1, 2, 3, 4 track, the source asks an even wilder question. What happens if we go backward?
Yeah.
Like, what does a negative beat physically feel like in your muscles?
It's wild because when most people think of a minus sign in music, they just assume it means play slower or, play quieter.
Right, like negative volume or something.
Exactly.
Yeah.
But the drummer's text is adamant here. A minus sign is not a volume knob. It represents direction.
Direction. Okay, so negative 4 4 time means you strike upward.
Yeah, the table is still divided into 4 slots, but you are hitting it from below. The physical energy travels in reverse.
The guitar analogy they use here is actually perfect for visualizing this, I think. If you play guitar, a hammer-on is a downstroke.
Right.
You are adding energy to the string by physically striking your finger down onto the fretboard.
And a pull-off is an upstroke.
Right.
You release the energy by lifting your finger away, literally pulling the string outward.
Right, so a minus sign simply tells you which way the physical energy is flowing into the instrument, but the author goes so much deeper than just putting a minus sign in front of the whole time signature.
Oh, they go way deeper.
They start putting signs inside the fraction itself. Like, they assign a positive or negative value to the outer motion, the numerator, and the denominator separately.
Let's walk through the physical mechanics of this because I think it induces incredible cognitive dissonance when you try to do it.
It really does.
Let's take the first example. Say you have a positive outer sign, a negative numerator, and a positive denominator.
Okay.
So in notation, that's a plus sign on the outside and then -4 over +4.
Okay, let me think about my arm moving. The outer plus sign means this is a standard downstroke event, right? I'm striking downward toward the table.
Right.
The positive denominator, the +4 at the bottom, means the floor, or the table, is divided into normal forward-facing quarters.
Yes. But the numerator at the top number is -4. That means your internal count is actually running in reverse.
4, 3, 2, 1.
Yes.
So I am physically striking downward onto a forward-moving floor, but my brain is counting backward.
Exactly.
The source likens it to walking backward down a hallway where all the floor tiles are painted facing forward.
Right. Or dragging a guitar pick down across the strings, but your mind is counting the strings upward.
Man, it is literal cognitive dissonance mapped directly onto your muscle memory. It's like rubbing my stomach and patting my head, but mathematically.
And then the text asks the drummer to execute a triple negative signature.
Oh boy.
Outer minus, numerator minus, denominator minus.
Okay, let's break that one down. Outer minus means it's an upstroke.
Yep.
Numerator minus means I count backward. And the denominator minus means the floor tiles themselves also face backward.
Now, basic algebra tells us that a negative divided by a negative is a positive, right?
Sure.
So -4 over -4 is technically just a positive ratio. And then that outer minus flips the whole thing back to a single negative value. So algebraically, a triple negative equals the exact same scalar value as just a standard -4/4 beat.
Wait, okay, so if minus 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 basically just equals 1 minus, why even bother writing it out that way? Because, the audio would sound completely identical.
It would.
If you recorded a drummer playing a -4/4 upstroke and then a triple negative upstroke, the ear hears the exact same millisecond grid.
The ear absolutely hears the same audio. But here is the core insight of the entire text. Your body arrives at that sound via a totally different path through sign space.
A different path through sign space. Let's unpack that because that's huge.
Yeah, think about the performer's physical awareness, their proprioception. To execute that triple negative beat, the drummer's wrist had to internally twist to accommodate the backward count, and then twist again to accommodate the backward floor before they finally deliver that upstroke. The ear is entirely blind to that journey, but the body remembers every single twist. Your muscles are telling a completely different dimensional story than what the microphone picks up.
So if rhythm has an up and a down and a forward and a backward, and if how you physically twist your wrist matters just as much as when the stick makes contact with the drum, then rhythm absolutely does not live on a flat timeline.
Yeah, it does.
Time is spatial. It lives in 3D space.
Which brings us to, I think, the visual masterpiece of the drummer's framework.
Right.
They ask us to throw the flat table away entirely.
Completely gone. So imagine your drumstick is now just floating inside a massive sphere in zero gravity.
Right.
There is no floor. There's no earth pulling you down. Your drumstick is just this rod passing through the dead center of this hollow ball. And the stick has two glowing tips. A glowing teal tip for positive energy and a glowing amber tip for negative energy.
So without gravity, the whole concept of down completely changes. Down is no longer toward the floor.
Right.
Down is simply wherever that glowing teal positive tip happens to be pointing inside the sphere.
And this is exactly where those internal plus and minus signs we just talked about become actual physical coordinates. The three signs, the outer sign, the numerator, and the denominator, they become the X, Y, and Z axes of a three-dimensional space.
Exactly. So instead of just positive or negative on a flat line, your stick can point to any of the 8 octants of this sphere.
Right.
If you play a standard, all positive 4/4, your stick is pointing forward, forward, forward. The teal tip hits the southern hemisphere of the ball.
But if you play that triple negative beat we just broke down, your stick is oriented backward, backward, backward.
Yes.
So time signatures are no longer just telling you when to hit. They are literal vectors.
Vectors, exactly.
They're telling you where to hit on the sphere, how the floor is internally tiled, and which way the energy is flowing upon impact.
It fundamentally changes the role of the musician, from someone just keeping pace to someone navigating coordinates.
This sounds exactly like a video game physics engine.
Oh, how so?
Think about a video game where your character is running forward on the screen, right? And suddenly you punch in a cheat code that flips gravity on the X, Y, or Z axis.
Okay, yeah.
The player's feet might land on the exact same pixel on the screen, just like the drummer's stick hitting the exact same millisecond in a song. But the character's physical orientation in the 3D space is completely upside down or twisted sideways.
Right.
The timing of the footstep is identical, but their physical attitude is wildly different.
That is a perfect physical translation. The sphere is the space of all possible attitudes of a strike, and the time signature is just the mathematical law dictating from which direction you approach the impact.
So we have built this amazing floating 3D sphere where drummers are, twisting their wrists to hit negative coordinates.
Right.
And if you're listening to this, you might be thinking, this is just a wild sci-fi thought experiment imagined by a drummer with way too much time on their hands.
Which is fair to think.
Very fair.